Hello everybody, this is Digital Blackboard by Sachin P. Nagmute. In this video, we are going to discuss the topic Solve Problem of Source Transformation. So before discussing that problem, we will see one rule, that is equivalent of series combination of ideal current source and ideal voltage source. So we will find out what will be the equivalent if a ideal current source and ideal voltage source are connected in series. So here we can see I of t, that is ideal current source. Now why we are calling it as ideal current source? Because there is no internal impedance connected in parallel with it. So the internal impedance of ideal current source is infinite. Similarly, here we can see a ideal voltage source is connected. Now why we are calling it as ideal voltage source? Because we can see there is no internal impedance connected in series with it. It means the internal impedance of ideal voltage source is 0. So we are having two sources, current source, voltage source, both are ideal and both are connected in series. So what should be its equivalent, that we will discuss. So first of all, let us mark one current, that is IEQ, that is equivalent current reaching at this point. So we will find out this current IEQ. Now already we know that internal impedance of ideal voltage source is 0 and internal impedance of ideal current source is infinite. Therefore ZV is equal to, let ZV is equal to 0 and ZI is equal to infinity. Similarly, if we want to find out the total current or equivalent current reaching at this point, so by using Ohm's law, we know I is equal to V by Z. So total current will be equal to total voltage upon total impedance. So what will be the total voltage of this series combination? So the total voltage of the series combination will be always an addition. So V is equal to V1 plus V2. Similarly, total impedance of a series combination is addition. So Z1 plus Z2. So V is equal to V1 plus V2 and Z is equal to Z1 plus Z2. So as far as Z1 and Z2 are concerned, so it is very simple. Z1 is nothing but the internal impedance of this voltage source, that is ZV, and Z2 is internal impedance of ideal current source, that is Zi. So Z1 plus Z2 is nothing but ZV plus Zi. That is already known to us. But what about the V1 plus V2? So V1, let us, V1 is the voltage of this voltage source. So it is already given, that is V of t. So V1 is equal to V of t because it is already given, the voltage of this ideal voltage source is equal to V of t. But what about the voltage of this current source? It is given the value of only current, that is I of t. The voltage of this current source is not given. So let us find out what will be the voltage of this current source. So again we will use Ohm's law. So V is equal to IZ. V is equal to IZ. So what will be the voltage of this current source? I into Z. So I is given I of t and Z. Z is nothing but internal impedance of this current source, that is Zi. So the voltage of this current source will be nothing but I of t into Zi. So we got V1 is equal to V of t and V2 is I of t into Zi. So we will put the value, this summation of these two, that is V of t plus I of t into Zi in the numerator. So we are having total voltage V is equal to V of t plus I of t into Zi upon total impedance Z is ZV plus Zi. So we got the equation. Okay. Now we will put the limit. So total or equivalent current IEQ, if we put the limit, then we know ZV is tending to 0 and Zi tending to infinity. So ZV is equal to 0 and Zi is equal to infinity. So we are putting those limits. So we will put this limit in this equation. So after putting the limit in this equation, we will find that instead of Zi, what we can write? Infinity. And hence we are having V of t plus I of t into infinity. Okay, instead of Zi we have written infinity upon, instead of ZV what we can write? We can write 0 and instead of Zi we can write infinity. So it becomes 0 plus infinity. Now we will simplify this equation. If we simplify this equation, let us separate the numerator. So V of t upon infinity plus I of t into infinity upon infinity. So if we separate the numerator, we will be having V of t upon infinity plus I of t into infinity upon infinity. Okay. Now V of t upon infinity, so what will be V of t upon infinity? So if there is infinity in the denominator, the answer is 0. So we are having the first term is 0 and in second term I of t into infinity upon infinity. So infinity and infinity will get cancelled and only what will remain? It will remain only I of t. So we got 0 plus I of t. So finally we came to know that IEQ, that is the total current, equivalent current reaching at this point is only I of t, and I of t is the current of ideal current source. So the current which is reaching out of here, it is the current of only ideal current source. Hence there is no significance of this ideal voltage source. So we can conclude that equivalent of series combination of ideal current source and ideal voltage source is only ideal current source, okay. So I hope you understood this rule, okay. What is the equivalent of series combination of ideal current source and ideal voltage source? So if we are having one problem like this, we are having ideal current source of 5 ampere and ideal voltage source of 10 volt connected in series, and we have to find out this current time. So just within a second we can say, as the equivalent current is due to ideal current source only, we can remove the ideal voltage source. So only 5 ampere current source is there, and the current will be, current I is equal to 5 ampere. So by using that rule we simply got the value of current, okay, that is 5 ampere. Now depending on that rule we will solve one problem using source transformation. So the problem is, convert the combination shown in figure to a single source in parallel with single element. So the circuit is given and we have to find out a single source in parallel with single element. It means in a parallel a single element is connected, hence we have to find a current source, because only in current source there is an element connected in parallel. So we have to convert this network into a single current source. So let us start. So if you observe the network carefully, we will find that the 10 volt is the ideal voltage source and 6 ampere is the ideal current source, and both are connected in series. So by using that rule, what we can do? We can do one thing, as series combination of ideal voltage source and ideal current source is ideal current source only. So we can easily remove that ideal voltage source. So only ideal current source is there, okay. So we were having a series combination of ideal voltage source and ideal current source. So we removed ideal voltage source and we have only the ideal current source there, okay. Next, if you again observe the circuit carefully, we will find 10 ampere and 6 ampere are current sources connected in parallel. And this voltage source, practical voltage source, because there is element connected in series with this voltage source, so this is a practical voltage source. So here a practical voltage source is connected in parallel with the current sources. So it will be convenient for us to convert this voltage source in a equivalent current source. Why? Because then we will get 3 current sources connected in parallel, and we can easily combine if the current sources are connected in parallel. So we will do one thing, we will convert this voltage source into its equivalent current source. So how come? So see, according to Ohm's law, I is equal to V by Z. So we are having V is equal to 30 and Z is equal to 5. So 30 by 5. So 30 by 5 is equal to 6 ampere. And the element or the resistor which is connected in series with this practical voltage source, same resistor of 5 ohm we will connect in series with parallel with the practical current source. So we can remove this voltage source, and instead of that we will draw a current source of 6 ampere and a resistor of 5 ampere connected in parallel with it. So we got the circuit like this, okay. Now these 3 current sources are in parallel and the polarity of these 3 current sources are same, that is upward. So we can simply combine them, we can simply add these 3 current sources. So 6 ampere, so total current will be 6 ampere plus 10 ampere plus 6 ampere. So total current will be 22 ampere. So we can combine these 3 current sources and we can have only a single current source of 22 ampere, and the 5 ohm resistor will remain as it is, okay. So we got the circuit like this, okay. Now we can convert this current source into practical current source into practical voltage source. So converting practical current source into practical voltage source. So how we can find out the practical voltage source here? So again we will use Ohm's law. So V is equal to Iz. So I is 22 and Z is equal to 5. So we can have 110 volt, and the element which is connected in parallel with this current source, same we will connect in series with the practical voltage source. So 110 volt, 5. So we will remove this current source and instead of that we will connect one practical voltage source of 110 volt and 5 ohm in series with it, okay. So we got the circuit like this. Now next, if you observe the circuit carefully, we will find that 5 and J2 are connected in series. So we can take the series combination of 5 ohm and J2 ohm. Okay, so taking series combination of it, we can have an impedance of 5 plus j2. So we got the circuit. So we got only a single source now, but that single source is a voltage source, and we want single source in parallel with single element. So what we can do here, we have to convert this voltage source into current source. So how come? So I is equal to V by Z. So we are having V is equal to 110 upon Z is equal to 5 plus J2. So in the polar form we can get the answer, that is 20.42 at an angle of minus 21.80 ampere, and the impedance of 5 plus J2, which is connected in series with this practical voltage source, same has to be connected in parallel with the practical current source. So if we convert this practical voltage source into practical current source, the circuit will be like this. Okay, so we are having a current source and an element, single element, that is 5 plus j2 ohm in parallel with this current source. So this is our answer. So we had a question of convert the combination shown in figure to a single source in parallel with single element. So we got a single element, that is 5 plus j2 impedance in parallel with a practical current source 20.42 at an angle 21.80 degree. So we discuss in this video a rule, that is series combination of ideal voltage source and ideal current source, and by using that rule we solve one problem using source transformation. So I hope you understood this problem very well. So please like, share and subscribe Digital Blackboard. Thank you.